So let's make sure that's working. Okay. So quadratic formula, we now know that we can take the square root of negative numbers, right? And what is the square root of -1, guys?
The square root of -1 is I, or the imaginary number.
Okay. And what does I squared equal?
I squared leaves just -1.
-1, right? So if we end up with imaginary numbers, nice if we can end up squaring some of them and end up with real numbers, okay? So here's our quadratic formula. You need to know how to use this, okay? Seems like a lot of you are remembering how to go about plugging things in and carefully doing order of operations and arithmetic, right? But what we didn't have is this part in here, and I won't test you on that. That's called the discriminant. You might have heard that word in algebra. That b squared minus 4ac. And if that, before today, if that discriminant, the b squared minus 4ac, after you plug stuff in, was negative, what happened? Well, look at the b squared minus 4ac. What is it under? What is that symbol that the b squared minus 4ac is under?
It's under the square root.
Square root. And
that means it'll be undefined.
Right. So if the b squared minus 4ac, after you calculate it out, was negative, then you had no solutions to that equation. Until now, right? Now we can deal with a negative, it's called a discriminant in there, okay? And so we have our complex format, right, which mixes real numbers and imaginary numbers. Remember, it's an A plus BI form, right? The A is the real part, and the I is the imaginary part, okay? So let's just go down here and see how this works. So in exercise 1, we want us to use the quadratic formula to find all solutions, okay? So let's start plugging in. What's the value of A in this? X squared minus 4x plus 29.
A will be 1.
It's 1, right? And what's B?
B will be -4.
And C is
29.
Right? So let's plug it in, right? So X equals negative B. So -4, right? Negative B plus or minus the square root of -4b squared minus 4ac all over 2 times a. All right. And so then, some of that you might need your calculator for. Maybe you don't. So the -4 becomes +4, right? Plus or minus the square root of 16, right? Minus, there's no negative times a negative in there. 4 times 29, I believe that's what, 116, right?
Yes.
All over 2. And then our 16 minus 116, 4 plus or minus the square root of, what would that be? That's an easy one. Come on. I'll just write it. -100, right? All over 2?
Yeah, -1.
Okay.
2.
What is the square root of -100?
What chapter is this?
What?
It's chapter unit 9, lesson 3.
Oh, yeah. We're on page 143, guys. So this would be -4 plus or minus what?
Plus or minus square root of negative. Oh.
Yeah, we got
that. Perfect.
100's a perfect square, right? What's the square root of 100, guys?
10. So square root of 10 times square root of -1.
Right. In other words, just 10i, isn't it? All over 2. Okay. But most of the time we want to get that in this form, A plus BI. It's not quite in that form, is it? So we just need to split it up into 2 fractions, right? So X equals -4 over 2 plus or minus 10i over 2, right? And what does that give us?
X equals -2 plus or minus 5
plus or minus 5i, right? And that is an a plus bi form. Does anybody have any questions on that? Okay, so it's just, I mean, you know how to use a quadratic formula. We're now just integrating it, you know, with the square roots of negatives and complex numbers, okay? So let's go down here. To solve these equations, does anybody see something that needs to happen first before we solve either of these quadratic equations?
We have to clean up the both sides.
Yeah, in other words, a quadratic equation, before you solve it, must equal
It
what?
has to equal 0.
Yes, it must equal 0. Okay, so this one in part A, does it equal 0?
No.
No, so what do we do about that?
We divide both.
No,
We subtract.
so let's subtract 10x from both sides, right? Put it under its like term. And we'll subtract 4 from both sides, right? Usually you don't have to write that, hopefully you don't. So what does that give us? X squared
X squared plus 6x plus 9.
plus what?
Plus 9.
Sure about that?
Oh no, plus 11. So
Yeah, 11 equals 0. Now it equals 0, right? So that's very important. Be a real big mistake, you know, if you called this your A is 1, B is 16, and C is 15, right? Because it's not, that's only the case if it equals 0, okay? Whoopsie daisy. All right. So now we identify A, B, and C correctly. Okay. X equals negative what?
negative 6.
Plus or minus the square root of what?
6 squared.
Whoops. Minus 4 times what?
1
Times
11.
11. All over
Divided by
2
2.
A, technically. Right? I mean, I almost will have to write times 1 down there if I'm trying to be efficient, but I don't want to leave things out and have somebody get confused, right? Okay, let's simplify this. Negative 6 plus or minus the square root of what?
36.
And then
Minus 44.
minus 44 all over 2. All right? What's that give us inside the square root?
Minus 8.
Of negative 8, right? All over 2. Well, let's simplify that square root of negative 8. Does 8 have a perfect square factor?
No.
Are you sure about that? Well, we know the I, we know that an I is going to come out, right? For the negative 1. Now let's break up the 8. What's the biggest perfect square factor of 8?
4.
4 was the biggest one. Times what? 2, right? Over 2. All right. Here we got that. What's the square root of 4?
2.
So 2i square root of 2 all over 2, right? But let's break this up. We want to get it into a plus bi form. It's not quite there, is it, right? So we end up with x equals negative 6 over 2 plus or minus 2i square root of 2 over 2. So what does x actually equal here, guys? Simplify this out.
X would equal negative plus or minus 1i.
Plus or minus, well, the 2's cancel here. What's left?
Just I.
I square root of 2.
Square root of 2.
Yeah, right, that didn't cancel out. All right, did I lose anybody there? Maybe the simplest radical form stuff. I know that's for some reason that's a tricky one for some of you guys. Okay,
Can you scroll up so I can finish the rest of that?
sure.
Can I just
And don't forget, guys, if you miss something, it'll be in the notes later. Okay, you can
Okay.
get out of there. All right, so what I'm gonna have you guys do is go over here to part B. And I want you guys to solve that. And I want it in, standard complex A plus BI form. But first, that equation has to equal what, guys?
0.
0. Okay? So let's all take a couple minutes and work through that and see if we can get the correct
Go
solution.
down to the last problem a little bit.
Yeah, can do. Good. Well, hopefully you've got it equal to 0 by now. Oops, 8x squared would be what, plus 24x plus 19 equals 0.
Yeah.
Right. Yep, keep going, plug in your A, B's, and C's. So let's go through this. And, if you didn't get that answer, we can figure out where you went sideways. So we got 8, 24, and 19, right? So we're going to do x equals negative b plus or minus the square root of b squared minus 4ac. If I make a mistake, somebody stop me. All over 2a, right? So that would be x equals negative 24 plus or minus the square root of, we learned is 576.
576 minus 608.
608 all over 16. Negative 24. Now we'll simplify that discriminant inside there. And I believe we get negative 32. I'll bet you there's a perfect square factor of 32, right? All over 16. So let's take out the negative 1 under that square root as an I. And what's the biggest perfect square factor of 32? You know your perfect squares.
16.
Mhm.
16.
16 and square
Okay.
2. Yep. All over 16. Let's keep simplifying. Negative 24 plus or minus what?
I4.
Well, if I prefer to write 4i, I guess. 4i
4i square root 2 divided by 16.
over 16. All right. So it's not quite an A plus BI form yet. And by the way, I'll stop. Did anybody get lost up to this point? Just please pipe up and say something. I'll go back and help you get straight. Anybody miss anything here? Hopefully we understand, 32 has a perfect square factor and how to break that up, okay? Well, let's split this into two fractions now, right? Both of them over 16, and then we can reduce lowest terms, right? Negative 24 over 16 plus or minus 4i square roots of 2 over 16, right? Better go back up top here. Get this thing out of the way. All right then, negative 24 over 16, what's that reduce to?
Reduce to negative 3.
Yeah, divide them both by 8, right? Negative 3 over 2 plus or minus. All right, the only thing we can reduce is that 4 over 16, right? What does 4 over 16 reduce to?
1/4.
So that's 1/4 I times the square root of 2. Okay. Does anybody have any questions on this one? If you got lost, if you're unsure about anything we did here, please say something now. You all good there? Hey, by the way, if we were to graph this thing in a coordinate plane, would it intersect the x-axis?
No.
No, because the coordinate plane's real numbers, right? And this does not have any real
Yeah,
solutions,
you have to
right?
use imaginary numbers to get the answer.
Remember, solutions are also known as zeros when you graph them, right? It's where the y value equals 0, and in other words, hits the x-axis. Okay? All right, let's flip over to the next page. We got one more example we'll take a look at. All right, so consider the parabola. His equation is y equals x squared minus 16 or minus 6x plus 13. All right. So in part A, algebraically find the x-intercepts of this parabola. Well, how would we do that? The x-intercept is found
We
where?
can sort y equals 0
The
times
x-intercepts are found where y
Zero
equals
squared.
0. So in other words, we're just setting this thing equal to 0, aren't we? Like we have been doing, right?
yeah,
To find, and by the way, the x-intercepts are called what? The zeros of the function, aren't they? Or in other words, solutions, okay? So let's set that thing equal to 0. So x equals x squared minus 6x plus 13. Oh, why did I do that first x? That was silly of me. How about just that? Okay? All right, let's plug into our quadratic formula. Okay? So x would equal what?
x would equal negative 1 negative 6
Negative b plus or minus
with
the
a
square
minus
root
square
of.
root of 6 squared, negative
I'm getting
6
ahead of
squared.
I'm getting ahead of myself here. Hang on. Sometimes I think a couple steps ahead and write it.
Minus 4 times 1 times 14.
There's your AC all over 2a. Okay, well, let's get to simplifying again then. It'd be positive 6, right? Plus or minus square root of 36 minus what? I think it's 52. Right, 4 times 13 all over 2.
Yeah,
Okay. So then I'll go back up top here. So x equals 6 plus or minus a square root of what?
x square root of negative 16.
Negative 16. Well, that's nice. It's a perfect square,
over
right?
2.
Right? Okay. It comes out nice and neatly, right? Kind of. Except for the imaginary part. What's the square root of negative 16?
Root of 16 would be 4. We have square root of 4
No,
times
not the
square
square.
root of 1, negative 1.
Okay, not the square root of 4. 4 is the
Oh.
square. So it's just 4i, right? The I
Yeah.
all over 2. Is it an a plus bi form yet, guys?
No.
Nope. So let's split it up. 6 over 2 plus or minus 4i over 2. And now let's reduce it. What do we get?
Three plus or minus 2i.
2i. All right. Any questions on that solution? We found the x-intercepts, also known as the zeros, also known as the solution, right? Okay. All right, over to part B, using your calculator. So we have our calculator we use to sketch a graph of this. We don't need to get nuts, right? So probably, like, if you remember, I think a table of values might be handy here, right? Because, and you don't have to write this down, but if I have a parabola, right? This is some center value, and it's all kind of symmetric, so we could find some middle value and get those points on either side of it to graph it correctly, right? So let's get a table of values, which means we'll need to put this in our super terrific happy fun time tracking calculator, whether you're using the one I shared with you or Desmos or whatever it is. So let's bring that up. All right. So we want to arrow over to functions. By the way, is this calculator screen sharing, guys?
Yeah.
Okay. Sometimes
Yeah, I see
everybody
it.
sharing window with the whole screen. Okay. So functions. So let's add a function. So hit OK. And I believe that was. Oh, that's up there. So x, my variable key, square thing here, minus 6x plus 13 plus 13. Okay. Well, let's see what the graph looks like, just roughly, and then we'll get a table. Then maybe we can get like an idea of where that center vertex value is, right? There's our graph, right? Now, I think it's automatically like in trace mode. Looks like that vertex is right around what?
Vortex is around
It's like 3,
4,
maybe?
like 3,
Yeah,
3.5. It's 3.5.
I guess they're going by twos, 2, 4. So let's just trace it and see. Yeah, it's not hitting it, but this seems to be about 3, right? So we need some values on each side of 3, right? Okay. So I want to go back up top here. I need to hit like this back out button and arrow over to table. Hit OK. So there's 3, right? I can adjust this table, right? See, we should set the interval. I hit this again, come down. So I just got my x starting. I don't know. Let's do like an x starting at down at whatever. How about -4? -4 to 10, and we'll step by 1. Whatever. All right, so we got roughly some points to plot there. I guess the thing I'd be really interested in, just doing a rough sketch, is what's the y-intercept? That's where x is 0, right?
The Y is 14.
Yeah, so it hits the y-axis at 13. And what is the lowest y value?
Lowest Y value is,
So, right, here's all the y's.
if you go down,
Lowest
it has
y,
to be 4.
yeah. And what's the x value that gives that low one? See how
3.
it climbs back up? It's symmetrical on either side of 3. So, what the x value that gave us that y value of 4 is 3, and we know we got an intercept of 10, right? So we don't need to get nuts. We just want a rough sketch, okay? So 3, 4 is a vertex, and then 10 on the y-axis, okay? Well, let's just put that in there. So this is going from, it's -5, right? So I'm guessing that's 10 out there, so that's going to be a 5, right? And then we said that's 20, so halfway up will be our 10. There's our intercept, right? And I don't know, maybe the vertex is 1, 2, 3, right about here, something like that. It's okay. But anyway, the important part about this is that what do you notice about this graph?
It never goes to X intercept.
Yeah,
It never
right.
reaches 0.
It doesn't have any. So remember, anything on this x-axis has a y value of 0, doesn't it? And it never has any zeros in the real number system, right? So in part C, what can we say, right, about parabolas whose zeros are complex? What do they not do? They do not
They never
what?
reach. They do not intersect
The
the X intercept.
x-axis, right?
The X-axis,
Right. So that means
which
it
is
has
X equals 0.
no zeros, which also means it has no real solutions, right? No real number solutions. Right? And up until you learn about imaginary numbers, you really had no way to handle that except to say it had no solutions. Well, it does. It's got 2 of them, okay? 3 plus 2i and 3 minus 2i, okay? These exercises we're going to skip. I'm going to skip this, all right? So does anybody have any questions on any of the stuff we've done here so far? It's really not anything new today, right? We already did the quadratic formula. We've already done imaginary numbers in complex a plus bi form, okay? Well, let me give you your problem set.
I have a quick question.
Yeah, go ahead.
Is it similar, the graphing looks similar to shifting.
Sure,
how we-
shifted, yeah, right.
No,
Shifting quadratics in this form, it's a little more complicated than just like adding things to the outside and the inside when it's a quadratic like that. So I'm not too worried about the shifting. You are right, it is shifted, right? It's not like if it was just x squared, it would be here, right? Like that. But then we got all this other stuff, and the 6x complicates things. We'd have to like put it in a different form to talk about the shifting.
oh, okay.
Right, like in factored form would be easier to see that, but we're not going to mess with that today, okay? All right, let me give you your problem set. So it's just going to be numbers 1 through 3, okay? Your problem set, numbers 1 through 3 in your book, okay? Any questions at all on this stuff, guys? Okay, don't forget to type here over on the chat thing so I can get you attended. And then I think when we come back at, boy, it's early, isn't it? How about at 9:15?
Okay.
We have one assignment. And then I think when we come, how many have started the review?
I think I get it.
Put a hand
Haven't
in.
started yet. I was about to say.
Okay. Well, if you get done with this assignment, why don't you get started on that review? And then after we go over this assignment, when we come back, I'll throw up the review answers. And whatever you got done, you can ask questions about. Okay? So we'll go over this assignment, and then we'll look at the review when we come back.
Is that all the notes we took? Just that?
That's it, just one section. So we'll be back at 9:15 to look at this assignment and the review. Okay?
Yeah.